In this video, we'll be looking at how to solve absolute value inequalities. And they're not hard, but they can get a little bit tricky, so it's really important that we are very careful here and pay attention to details. So first we're going to look at absolute value inequalities, that the absolute value, all right, so let's call this type 1. So in the first type that we look at, we want the absolute value to be of something, to be less than whatever number we have. All right, so in type 1, an example could be 2x plus 7 is less than 11. So let me make sure that you can see this clearly. All right, so again, 2x plus 7 is less than 11. All right, that just means that the distance of 2x plus 7 from our 0 on the number line has to be less than 11. So let's visualize this really quickly. Imagine 0 is right here. What numbers are less than 11 away from 0? And we can figure that out by just looking at this number line. Anything between negative 11 and 11 could be our solution, because all those numbers are less than 11 away from 0. Which means that now we can rewrite our inequality to show that 2x plus 7 has to be between negative 11 and positive 11. So once we understand that, now it becomes just a compound inequality. So let's solve this. We can subtract 7 from everything because we're trying to get that x alone. So on the left side we have negative 18 is less than 2x, which is less than 4. And now we can divide everything by 2 because we want to eliminate that 2. And we get that x is between negative 9 and 2. And that's our answer. And of course, we can go ahead and check it by just looking at any number between negative 9 and 2 and just making sure it works. So I like my little magic number 0 because it's really fast and easy to work with. So if we plug 0 into our original equation, so this is our check, so just make a note of that here. We plug 0 in, we get 2 times 0 plus 7 is less than 11, the absolute value. And that is in fact true, that the absolute value of 7 is less than 11. And so we're correct. If you try anything between our answer here, it should work out. So you can do a check if you like. In our second type of absolute value inequality, our absolute value expression will be more than or greater than the number. So let's just jump right into an example so you can see what I mean. So we're going to solve the absolute value inequality 3x minus 2 is greater than 8. All right, so what this means is that our expression 3x minus 2 will be, the distance of that expression away from 0 will be more than 8. So if we quickly look at a number line here, let's say 0 is here and negative 8 is here, positive 8 is here. So what numbers have a distance of more than 8 away from 0? What you'll be looking at is less than negative 8 and more than positive 8. So the numbers over here, let's point, the numbers over here have a distance of more than 8 from 0, and the distance over here also have a distance, the numbers over here also have a distance of more than 8 from 0, which means that our inequality for that greater than sign then turns to two inequalities, and they are 3x minus 2 is greater than 8, makes sense based on that, Or, on the other hand, 3x minus 2 is less than negative 8, which also makes sense because the numbers could be on this side, less than negative 8. So once we've figured out our two inequalities, now all we have to do is solve both. So let's do the one on the left side first. We can add 2 to both sides, and we get that 3x is greater than 10. Now we can divide both sides by 3, and we get that x is greater than 10 over 3. And that is one of our solutions. On the other side, we can add 2 to both sides to get that 3x is less than negative 6. And we can divide both sides by 3 to get that x is less than negative 2. And that is our other solution. And of course, we can check our answer. Always advise maybe plug in a number to check if it works.